Have you ever wondered how your favorite Netflix show streams seamlessly to your device? Or how your video calls stay crystal clear even when you're miles apart? The secret lies in two key concepts: frequency and data rate. Before we get into the calculations, let's define the key terms. First, frequency. This is the number of wave cycles that occur in 1 second, measured in hertz. For example, a frequency of 1 hertz means 1 wave cycle per second. Next, data rate, also known as bit rate. This is the amount of data transmitted per second measured in bits per second. Higher data rates mean faster transmission of information. Lastly, bits per cycle. This refers to the number of bits, that's zeros and ones, that can be transmitted in a single wave cycle. This value depends on the modulation scheme used in the communication system. The relationship between frequency and data rate is expressed by this simple formula. Data rate equals frequency times number of bits per cycle. This formula is the backbone of data transmission. Let's consider an example. Suppose we have a signal with a frequency of 1 megahertz, which is 1 million cycles per second, and each cycle can carry 2 bits of data. Using the formula R equals F times N, R equals 1 megahertz times 2, which equals 2 megabits per second. This means the data rate is 2 million bits per second. To visualize this, imagine each wave cycle as a container. The frequency determines how many containers are sent per second, and the number of bits per cycle determines how much data each container can hold. By multiplying these two values, we get the total data rate. Now that we understand the formula, let's explore how it applies to real-world technologies. Consider your home Wi-Fi network. Most Wi-Fi routers operate at frequencies of 2.4 GHz or 5 GHz. Let's calculate the data rate for a 5 GHz Wi-Fi signal with 4 bits per cycle. Using the formula R equals F times N. R equals 5. Gigahertz times 4 equals 20 gigabits per second. This means the Wi-Fi network can theoretically transmit 20 billion bits of data per second. However, in practice, factors like signal interference and network congestion can reduce this rate. Another example is 5G cellular networks. These networks use high frequencies, often above 24 gigahertz, and advanced modulation techniques to achieve data rates of up to 10 gigabits per second or more. This enables faster downloads, smoother streaming, and better performance for applications like virtual reality and autonomous vehicles. By understanding the relationship between frequency and data rate, engineers can design communication systems that meet the growing demand for faster and more reliable data transmission.